put in, like, let's say, for example, 4. They would go, oh, put in a 9, 10 over 0, can't do it. Well, the whole idea of calculus is to figure out what dividing by 0 means. So we can't stop there. So you can't just put in 9 and go 10 over 0 doesn't exist. What we have to do instead is graph it. So what we talked about, because if this were a non-calculator question, get your vertical asymptote, x is 9. Get your horizontal asymptote by shortcut rules for rational functions, so y equals 0. Any number I put in to the left and the right of 9 are both positive, so I know what it has to do based on the asymptotes. So the answer isn't doesn't exist. The answer is infinity. It's the biggest thing I saw in one of those worms. Like, ooh, and we talked about it at that time, but I want to point it out again. Any numbers on 2 to 4, any of those examples that are really sticking out that gave you some problems?
So it's just kind of like a general question, but can you like show one that you can do with L'Hopital's?
Yeah, anything that comes out to be 0 over 0. So I'm going to look at example 3 on page 3. So if I would use, and I didn't use L'Hopital's rule on this one, okay, because I saw that special trig limit, but I could use L'Hopital's rule if I wrote that and then wrote L'Hopital's rule, LH. And then limit as x approaches 0. Now I'd have to take the derivative of the top, which is going to require me to use what? The product rule, right? V u prime plus u v prime. And then the derivative of the bottom. And then once you get that, because we could use L'Hopital's rule because of the 0 over 0, now I can put in 0. These are going to be zeros. Cosine of 0 is 1, so I'll get 6/5. Okay, so that's a case where you can use L'Hopital's rule. You have to do direct substitution first. You have to tell them that you got 0 over 0. You have to tell them that you're using it. Okay. Remember, you can use it repeatedly. So let's say you did it once and it didn't work and you got 0 over 0, you can use it again. Get 0 over 0, use it again. Or infinity over infinity.
So this is also a general question. So in example 2 of page 3, you use like 7.9 and 8.1, like really close to -8. Could you use like -7 and
Oh, what we're looking at example 2